Good morning, boys and girls. Happy to be here with you all on this Tuesday morning. Today we're going to continue our study of the Pythagorean theorem. What you should have in front of you is something to write with, a calculator, and your class notes. You picked these up at the school with your Chromebook a couple weeks ago before the spring break. Please pause the video right now and go get those. I'm going to click over to my digital notes and work there. And this is where we're going to get started, okay? We remember that the Pythagorean theorem helps us find the side lengths of right triangles, okay? And today we're going to apply that to three-dimensional shapes. So we remember that the hypotenuse, or side C, is the side opposite of the right angle, right? The hypotenuse, side C, is opposite the right angle, okay? And the legs are the sides adjacent to the right angle. The legs are adjacent to the right angle. Adjacent means next to, right? So here, this and this are the legs, and then my hypotenuse, or side C, of that lower triangle is right there. You can't really see that very well. I'm gonna change those colors for you. I'm gonna get rid of that. I'm gonna do maybe orange. Let's try that. The hypotenuse. Let's try and make the hypotenuse right here, opposite of that right triangle, and then the green sides. The green sides. Let's see here. The legs are 1, 2 right there. So those are going to be A and B, and then C is going to be the hypotenuse, or the long side, or the orange side. The hypotenuse of the right triangle is always the longest side, okay? So now we can use that information and apply that to finding diagonals inside of these rectangles or squares. So we've got two triangles down here in the bottom left, right? You can see I'm going to take that away, and I'm going to do two different triangles, right? I'm going to do one green. I've got a green triangle right here, okay? And then we have an orange triangle right here. And you have to imagine that orange triangle is kind of going from corner to corner inside of that box. And the green one is along the flat bottom side of that box. And if we know the outside dimensions, well, then we can find those diagonals. Okay, so here's an example. In this example, it says a box used for shipping narrow copper tubes measures 6 inches by 6 inches by 20 inches. Right? So I've got this box. It's 6 inches by 6 inches by 20 inches, right? It shows that right over here. 6 by 6 by 20. Okay? What is the length of the longest tube that will fit in the box, given that the length of the tube must be a whole number of inches? So we need a whole number of inches. So we're going to have to round our final answer. The length of the tube must be a whole number of inches. What is the length of the longest tube that will fit in the box? So I can fit a tube in that box, right? And I can fit it in there from corner to corner right here. And that would be the longest length that I could put in there. Okay? And that piece right there would be the hypotenuse of this triangle right here. But to find that using the Pythagorean theorem, first I need to find that first hypotenuse. I need to find the length of S, right? Because I have these two right triangles here. I know the corners of this rectangle are right angles, right? So this is a right angle right here. That's 90 degrees. So side S is actually side C. and side R is actually side C. And then side L, which is 20 inches, well, that could be A or B. And then the other side, this side right here, is 6. So this side here is also 6 inches. And let's see, this right here, the height is 6 inches. I'm going to make that a different color. I'm going to make that red. That's red, that's 6 inches. So this over here is also 6 inches. Right? So now I've got these two right triangles. And using the Pythagorean theorem, which tells us that a squared plus b squared, the sum of the squares of the legs is equal to the square of the hypotenuse, the long side. And we said that a was 20 and b was 6. Right? So we're going to square both of those values, and that's going to equal c squared. Okay, so that's 400 plus 36, plus 36 equals c squared. So then if I take the square root of 436 and the square root of c squared, I'm just going to grab my calculator. I'm going to do the square root of 436, and I get 20.8806 ... approximately 20.8806 1302 is what's in my calculator here. Okay, and I don't really want to get rid of that yet because that side C is now one of my legs in my second triangle, right? So C is now going to turn into B. So I'm going to take that value and I'm going to raise that to the second power, right? Because 6 squared plus S squared is equal to R squared, right? S is our first C value. So I'm gonna plug that in right here, and I'm gonna square that. So up to the second power equals, so that's 436. I'm back to 436 because I have to square that, right? So it's 6 squared plus 436 equals R squared. And 6 squared is 36. And 36 plus 436 is 472. And then I'm going to have to find the square root of that to find the length of R. Second, x squared, 472, enter, 21.72. So if I take the square root of both of these values, I get 21.72, approximately being the length of R, or the diagonal from corner to corner across that rectangle. And it says that the length of the tube must be in whole number inches. Okay, so if it's 21.72, well, I can't fit a 22-inch copper tube in there. I can only fit a 21-inch copper tube. So it says, what is the length of the longest tube? We're going to say the longest tube that will fit. The longest tube that will fit in the box is 21 inches long. And that's our answer. Okay, now I'm going to move on to the next problem. If you need to pause, just pause, get what you need, finish up. I'm going to go to the next page. We're going to look at another example, sort of the same thing. Okay, again, we've got these two right triangles, right? We've got the one on the bottom, and then we've got this one that kind of goes from corner to corner. Okay, so two right triangles in there. So the first one, I'm going to look over here and see what we've got going on. Tina ordered a replacement part for her desk. It was shipped in a box that measures 4 inches by 4 inches by 14 inches. All right, so these are the dimensions of the box, 4 inches by 4 inches by 14 inches. So I have the length and the height and the width. And I want to know the greatest length in whole inches that the part could have been. So that's what I'm being asked. How long could the part be? Read it until you understand it. Okay. So my first triangle, let's see, try and highlight this here for you. My first triangle down here, right, is flat across the bottom of this box. It's a diagonal across the bottom and the two outer edges. Okay, so I know this is 4 inches right here, because I know that this side of the box is 4 inches, and this side is labeled as 14, right? And those are my two legs, because I know the corner of a rectangle is a 90-degree angle. And so what I'm looking at here is 4 squared plus 14 squared is equal to c squared. And in this case, c is right here. C and s are the same thing. So I have 16 plus 196, right? 4 to the second power plus 14 to the second power is 212 is equal to c squared. And I can find what c is right here by taking the square root. But then in my next equation, what I'm going to do, right, my next triangle is up here. My next triangle is this one up here, this blue one that I'm highlighting right now. Okay, so one of my legs is going to be the old C. The old C is becoming an A or a B. So I need to square whatever that is. So I can take the square root of 212. And that's going to be 14.56 approximately. Taking a step back here. 14.56 is approximately C. Now I'm going to plug that into my new equation, because this is 4, so is this. Now I have a 4 and a 14.56 are the legs. So I'm just going to take that answer that I still have in my calculator, and I'm going to raise that to the second power, and I'm right back to 212. Okay, so I'm at 4 squared plus, well, the square root of 212 squared is equal to c squared, which is this right here now, which is r. We're just going to say that's r. Okay, 4 squared is 16 plus 212, 212 plus 16 equals, so that's going to be 228 is equal to c squared, and I need to take the square root of both sides to find what c is equal to, or the length of r. They're the same thing, right, in this case. So 15.09, 15.099. So 15.1 is approximately C. Okay, and it says, what is the greatest length in whole inches that the part could have been? Whole inches. We need to know what whole numbers are. Right, so the greatest length in whole inches, well, I can't fit 16 inches in a 15.1 inch diagonal, so 15 inches is the greatest length. The maximum length or the part would be 15 inches. 15 inches. Those are the units on the box. And that's our second problem. So if you need more time, please pause the video, and if you're ready to move on, I'm going to go on to the next slide. We'll keep this rolling here, okay? Three-dimensional shapes and the Pythagorean theorem. Okay, this one says, Mr. Wu wants to ship a fishing rod that is 42 inches long to his son. He has a box with the dimensions shown. Find the square of the length of the diagonal across the bottom of the box. Find the square of the length of the diagonal across the bottom of the box. So it's telling me first to find this right here, this blue line. Find the square of the diagonal across the bottom of the box. So I need to find the length of the diagonal across the bottom of the box. And I know that the outside dimensions of that box are 40, right here, 40 inches by 10 inches by 10 inches. Okay, so this rectangle here, well, this side is 10 inches. So this side is also 10 inches. And so now I have this right triangle down on the bottom of the box. And this side is my hypotenuse. The blue labeled side is equal to C, right? So I'm going to do 10 squared plus 40 squared equals C squared. And so 100 plus 400, oh no, that's not 400, that's 1,600, is equal to C squared. And so 1,700 is equal to C squared. Okay, it asked me to find the square of the length of the diagonal across the bottom of the box. So that's what I have right there. The length of the diagonal, we called that C, and we have C squared is equal to 1,700. So C squared is equal to 1,700 inches. Okay, now it says find the length from the bottom corner to the opposite top corner. From the bottom corner to the opposite top corner, will the fishing rod fit? So it's basically asking us, I'm going to highlight this green. It's asking us, will the fishing rod fit right here? Okay, so my new triangle, this green triangle right here, right, I know that my side, one of my legs, this side right here, one I just highlighted black, is 10 inches. Right, opposite sides, this one over here. And the one on the left and right are both 10 inches. And now I know what the hypotenuse is. Or I know what this side is right here. My old C, right? I have A. My old C is my new B. Okay, so I'm going to do 100 squared. 100 squared plus, well, I don't need to square this. It's already, C has already been squared. So I'm just going to leave it that way. And now I have 100 squared. Oh, no, that should be 10 squared. I'm sorry. My mistake. 10 squared plus 1,700. In math, we're always going to make mistakes. Show your work and be able to find them. Okay, so now I have 1,800 is equal to c squared. And if I take the square root of that, I can find the length of the diagonal on the inside of the box. So I'm going to do the square root. Second x squared 1,800 equals 42.426. 42.426 inches is equal to c. So this diagonal across the top is 42.426 inches. It says to the nearest tenth. So I'm going to round those. I'm going to get rid of that. And I'm going to leave 42.4 inches. Will the fishing rod fit? How long is the fishing rod? 42 inches long, and we have 42.4 inches to work with. So yes, the fishing rod will fit. Because the diagonal inside the box, when we explain these things with words, we understand them better. When the fishing rod will fit because the diagonal inside the box is 42.4 inches. And that's the last slide we're going to do today. Then I'm going to have you do a little bit of classwork, so you can pause this, rewind, do whatever you have to do. And I'm going to turn this off and get the next thing going.